This lecture will focus on basic definitions and try to break down the word probability. So what do we do now? Let's read the definition of probability. First, probability is the measure of the likelihood and chance that an event will occur. What do we do now? We'll break down each word one by one. Likelihood is chance, and probability is the event that occurs. What do they all mean? Probability, in simple terms, describes the likelihood of something happening. So why don't we simply say the chances of something happening? Why did we use the word probability? Why don't we simply say chances? We say that to quantify it, because your computer speaks in numbers. Let's take anything. Let's say there's person A and person B now. Person B is wealthier or richer than A, but how rich is he? So we have to quantify that, saying that A earns 1 lakh rupees more than B, so we've quantified it. So, when we quantify these chances, the possibility of something happening. Quantifying means assigning a number to something. When we quantify it, we call it probability. And there's a range for quantifying it. That range is between 0 and 1. Now, 0 and 1 also have their own meanings. What do 0 and 1 mean in themselves? 0 means that an event is impossible. If I say, what are the chances that the sun will rise from the west instead of the east? That's an impossible event. So, the probability that the sun will rise from the west is 0. And if I say, the probability that the sun will rise from the east, so its probability will be 1. This means it's a universal truth. It will definitely happen. If anything has a probability of 0, then it's impossible. It can never happen. And if anything has a probability of 1, then it can never happen. We've just defined probability. We haven't yet explained how to define probability in mathematical terms. Before that, we have to define an event. Even before an event, we have a definition. That definition is the sample space. Now, what is a sample space? Suppose you throw a dice. So, when you throw the dice, what are the possible numbers that could come up? 1, 2, 3, 4, 5, 6 is the set of all possible numbers that could come up, and this is the sample space. If I were to define a sample space, the sample space is the set. What we write in curly brackets is the set, and all the values in it are unique. This is a property of a set. The set of all possible outcomes. Now, if you throw a die, the set of all possible outcomes is numbers from 1 to 6. No more, no less. So, this is your sample space. Now, let's return to the event. Suppose you have an event. What is an event? I'll give you a case. The case is that if you throw the die, the number that comes up is odd. Odd is our case. So, what are the odd numbers in this case? Our odd numbers are 1, 3, and 5. These are our odd numbers. Now, I'm telling you that I want to find the probability that the numbers that come up are odd. So, the odd number that comes up here is your event. These numbers are 1, 3, and 5. If we read this again with the definition, probability is the measure of the likelihood and chances of an event, and the event that the number comes out to be odd will occur. So, if we want to calculate the chances of an odd number coming up, then any odd number here, this set of odd numbers, will be your event. One property you'll notice is that an event will always be a subset of the sample space. Your event will never go outside the sample space. So, we can define it this way. An event is something that, and an event is always a subset of the sample space. In simpler terms, an event is a sample space. Sample space means all possible outcomes, and out of all those possible outcomes, you need to calculate the probability of something certain. If I roll the dice, I should see the number 5, and that number 5 should come up. So, that's your event. If you want to select some certain set from the set of all possible outcomes and find their probability, we call it an event. Mathematically, such an event is a subset of a sample. Here, E is your event, and S is your sample space. There are many types of events. We'll discuss that in the next lecture. Before that, let's define probability further mathematically. Now, you saw the event here for odd numbers. What was its set? 1, 3, 5, and what was our sample space? 1, 2, 3, 4, 5, 6. This is our sample space. Now, if we want to find the probability of the event that an odd number will occur when throwing the dice, then to find the probability of any event, we divide the number of elements in the set of events by the number of elements in the sample space. How many elements are there in it? The number of elements in this is n, meaning the number of elements in the set E equals 3, and this is what we need to calculate for the sample space. The number of elements in the sample space is 6. So, the chances of rolling an odd number on your dice is 3/6, or 1/2, or 0.5. Now, from this 0.5, we get 50%. So, what happens? If you want to write 0.5, you can write it like this. 50% up to 100 and divide by 100, that gives you your percentage. Now, why did I write this as a percentage? Your 50% describes that if you roll the dice 100 times, an odd number will appear approximately 50 times. If the dice is fair, then fairness and unfairness are also a topic in itself. We'll discuss it in the next lecture, but for now, understand that if you roll the dice 100 times, you're throwing the dice 100 times. So, approximately 50 times, an odd number will appear. Our probability tells us that any number that appears in probability, 0.5, 0.6, or 0.7, indicates that if you throw the dice 100 times, the same thing will happen 70 times. If you throw it 100 times, the same thing will happen